Potter to come up, and she will present on the second-year findings of AgTiv Mycorrhizal Inoculant trial on potato and cereal crops. Can you help me welcome Emily?
Okay, so as mentioned, my name is Emily Potter, and I am the Executive Director for the Northern Ontario Farm Innovation Alliance. So we are an organization that does applied ag research to advance agriculture in Northern Ontario. So we are overseeing this project called AgTiv Mycorrhizal Inoculant on potato and cereal crops, which is a collaboration with the Northeastern Ontario Soil and Crop Improvement Association and the Nipissing West, East Sudbury, and Sudbury local associations. Not that one. Okay.
That one there, you can just hit it hard.
Okay. Anyways, the goal of this project is to determine whether a mycorrhizal inoculant will be effective in northern climates on improving yields and crop quality, leading to an overall increased revenue for farmers. So this here, we're just checking the roots on some soybean plants to see if you can see the effect of the inoculant working on the plant, so looking for fibrous root development and increased nodulation on those plants. And the inoculant should improve the overall plant health and then help build some soil structure with that increased rooting system. Oh, it worked. So how this process works is mycorrhizae, they are found naturally in the soil, but then when you disturb that soil, the population greatly decreases. So adding the inoculant back in helps to form that symbiotic relationship between the mycorrhizae species and the plant roots. And then those species help to increase the intake of nutrients and water in the soil, which stimulates healthier plant production, just overall more vigorous plants. And can lead to potentially a more disease-resistant, drought-tolerant plant. So just looking at some previous research that was done, as you can see based on these results, using this inoculant helped to increase those yields. The one to look at specifically is potato yield, as you have to look at both the harvest yield and the marketable yield that you're getting out of the field. So that's pretty important, and half our trials are potatoes. Our project partners, again, we were working with those three associations plus our 4 farm cooperators, so they helped us with those farm cooperators. We're also working with the Sudbury College Boreal campus to do some on-ground work for us in the fields and to build some additional research projects out of this project. And then Tech Agriculture is helping us with agronomic support, and Premier Tech is where we are getting our product from. So site selection, at our 4 farms, we have 2 plot locations. They're 5-acre plot sizes, and at each site, 1 plot is on a higher fertility field and 1 plot's on a lower fertility field based on what the farmer already knows about their field. And we're looking at inoculated versus non-inoculated strips, so as you can see here, and then working with what the farmer has available to them for equipment. So the 3 different products we were using, again, it depended on what worked best for each farmer, but for soybeans, it's a powder product that you mix with the seed at planting, and it has both a fungi and a bacterial species in it. The potatoes, a liquid, and it's an in-furrow application, and then the field crops powder that we were using on our oat crop were mixed with seeding at planting time. What we're looking for is soil sampling and then looking at basic plant assessment to see if there's any issues there with plant health, diseases, things like that, and then specifically yield and quality. So I'll touch on results now. So something I didn't mention at the start is that in year 1, we weren't able to get the product in the ground just due to timing. So we actually, this past year was actually our first year of real results. And we did have a few challenges again with 2019, very wet spring specifically. Our potato crops did not get in the ground as soon as we would have liked, and then that led to issues down the line. But I'll start by talking about our soybean plots, which we ended up including soybeans in the trial because it worked best with what the farmers were doing in their rotation, and it's easier to work with what's going on farm instead of changing what they are doing. So for the soybeans, we were planting into ground that was lower in phosphorus and potassium, and then the difference was a bit of higher organic matter in our high fertility field. So as you can see here, and I don't know which is the pointer. Okay, I'm not gonna try that. Anyways, the one on my left, your right, is the one that was treated. So while ignoring the top portion of the plant, because I'm not really sure what was going on there, you can see that there's a lot more root development. So those roots are getting deeper into the ground, and there's a bit more root structure there. And then when we went back later on and did a pod count before harvest, there was a greater number of pods on the plants that were inoculated versus not. And then overall, with working with our agronomists, they found that the treated areas averaged about 2.05 bushels per acre more yield than the untreated, and he did a little economic translation of that into about $22 per acre more in revenue. So looking at our oat trials, again, we were planting into lower phosphorus and potassium fields. And it was a lot harder to see in the root structure, but there still is, again, it's on my left hand, the one that were treated, but a little bit of difference there, but it was a lot harder to see, and that showed in our results when we saw about a 1.5% greater yield in the treated reps, which really isn't that much, but it was kind of interesting to see as we figured that could result into up to a $10 per acre increase in revenue. So it was still something to look at, but not necessarily statistically significant. And then our potatoes. So we did struggle a little bit with our potato fields, but this kind of gives you a really good picture. It was really easy to see in the potato fields out of all of our trials. You could just walk in the field and visually see which had been treated and which hadn't been. So on the far side, again, you can see a lot more root development. And then this picture is, I wish I'd had a picture of the whole field, but this was a side-by-side comparison. The one on this side is not treated, and the one on that side is treated, so there's a lot more plant development there. And then for potatoes, we did struggle with a little bit of harvest data collection. The equipment wasn't quite set up properly, but so we ended up getting a bit of an estimate on our yield, which was about a 15% difference in the treated versus non-treated, which we figured was safe to say based on the previous results done, but that's something that we're working towards this year, is making sure we can get some more accurate data on the potato plots. And so moving forward, our results are going to be posted on the NOFIA and Farm North websites, and we've been doing presentations on preliminary results to our regional associations and have some crop tours and field days planned for the upcoming year. Again, we did release a one-year report and are working to release that, and that'll be up on our website, but it's only 1 year of data, so I don't really, and it was 2019, so, take it how it is. But yeah, looking forward to this coming year. Any questions?
Are you in a full tillage program, all those crops?
Yes, conventional.
The reason I asked that question, if you're in a no-till program, maybe you wouldn't have to inoculate every year. Would that be true? Would it survive from 1 year to the next year?
So that's one thing that we're trying to look at with some soil sampling, because we aren't sure if the inoculant will survive, if the species will survive the winter in the cooler climate. So that's something that we are trying to figure out if that will stay. I don't have a better answer on that yet, but
My question is very closely related to that one. Did you notice any difference in soil quality? Because usually a good quality soil should have enough mycorrhizal fungi in it, and if it could be a poor soil, organic matter soil, or poor quality soil might respond
Okay.
better to that. Did you notice anything?
yes, so actually the inoculant showed a greater response in our lower fertility fields compared to our higher fertility fields, and that's good that you brought that up because I forgot to mention that.
We're gonna cut the questions off there because we're, well, you're okay. Well, can we thank Emily for a great presentation?